Hello and good evening students. This is Om Narayan Satyarthi and today I will going to teach you physics of class 10th. In this lecture we will going to solve the previous year board examination questions, but we will going to solve only physics questions which have came in the board examination 2020. But before starting I would like to tell you about what is the pattern of the paper with the number of questions that will come in board exam. So this is the simple marking scheme of class 10th which you can see here. In this you can see that there is 1 marks question, we call it to be very short answer type question, and in this very short answer type question you will have 4 parts. That is, the first part will be multiple choice question, the second part will be some reason assertions, and there will be a third type of questions which will contain only one word answer, and the fourth is one paragraph will be given to you, and based on that paragraph 4 questions will be there and you have to answer that 4 questions. This will contain total of 20 questions and each will carry 1 mark, and which will make a total of 20 marks. Then the next type of questions that will come will be of 3 marks questions. This we call it to be short answer type questions. This will contain a total of 10 questions which will count to total of 30 marks. And then there will be 5 marks question. There will be 6 questions which are of 5 marks and which will make it to be 30 marks. So when we count all, it will become as 80 marks question paper, and this question paper will contain a total of 36 questions. And in these 36 questions you have some 2 choices in 1 mark question, you have then 3 choices in 3 marks question, and you have 2 choices in 5 marks question, but all will be of internal choices. There will be no overall external choice of the questions. So starting with the first question of physics that came in board examination of 20. See, the first question says that the values of milliampere and microampere are, and they are given 4 options, and they are asking about what is the value of milliampere and what is the value of microampere. So we know that the value of milliampere is 10 to power minus 3. This milli means 10 to power minus 3, and if A is written here, then ampere stands for current. So this is milliampere. So we know that this milli means 10 to power minus 3. So our answer will be either B or either will be C. We will not going to see about A and D. Now what is the value of this mic? For this I have given you one scale. I was not getting the current scale, so I have used this length scale, that is this meter scale. So at every place where meter is written, you just cut this meter and write ampere, and all the values will remain same. So you can see here milli is 10 to power minus 3, and from here when you will see for this micro is 10 to power minus, this is given as 10 to power minus 9, and here it is given as 10 to power minus 6. So our answer will be this B, and this C will be wrong, as the value of micro is 10 to power minus 6 and not 10 to power minus 9. So coming towards the next question says that a cylindrical conductor of length L and uniform cross section area has resistance R. Another conductor of length 2.5 L and resistance 0.5 R of same material, they are asking about what will be the value of area of cross section. See here what they have given. They have given that the length has been increased to 2.5 L, 2.5 times the original length, that is L, and the resistance has been reduced to 0.5 R, half the resistance of original conductor. So they are asking what will be the area of the new conductor. So what we will going to do, we know that the resistance is equals to rho times L by A. So what will be the value of A? We can calculate this. A will come this side and R will come in the denominator here. So what will become, A will be equals to rho L by R, and then put the new values. So when we will put new values, we will write A dash, because we are getting new area, so we are representing it by A dash. So A dash will be equals to rho, and L will become as 2.5 L, and at the place of R we can write 0.5 R. So remove the decimal places, so this will become 25 by 5. Remove this decimal place here, and this 0.5 will come this side. So this will become 25 L upon 5 R. So this will be 5, because this 5 will cancel this 25 in 5 times. So this will become 5 rho L by R, and we know that from this equation that rho L by R is A. So we can have the new area as A dash will be equals to 5A, and hence you can say that option A is correct. Now moving further to the next question, The next question is reason and assertion question, and the assertion is saying that at high temperature metal wires have greater chance of short circuiting, and the second it is saying that both the resistance and resistivity of the material vary with temperature. So when you observe this first statement that at high temperature the metal wires have greater chance of short circuiting, yes, it is correct, because at high temperatures what will happen, that it might happen that the wire will going to melt, and hence it will create some chances of short circuiting. And what the second statement is saying, that both resistance and resistivity of the material will vary with the temperature. Yes, if you increase the temperature, then what will happen, the resistance as well as the resistivity both will going to increase. But you can find any relation between these two, that if it is saying that on increasing temperature the resistance is increasing, and in the assertion what it is saying, that at high temperature the metal wire has high chances of short circuiting. These both the statements are correct, but both are not related. Why? How we can say that it is not related? Because see, if you increase the resistance or resistivity of the wire, it will not going to happen that short circuiting will take place. So what we can say, that assertion is true, reason is also true, but it is not true that due to increase in the resistance short circuiting will take place, and hence option B is correct, that is both assertion and reason both are true, but reason is not the correct explanation of the assertion. Now moving further to the next question. The next question says, draw a ray diagram in each of the following cases to show what happens after reflection of the incident ray when it is parallel to principal axis and falling on the convex. So see, this type of question we have done in our class also. So I have taken one slide from the previous class, and see here we can see that rules for drawing ray diagram when we have discussed. There in the first rule what we have discussed, that when a light ray is parallel to principal axis, after reflection it will pass through focus. Now see, here it is saying for here I have drawn for both the mirrors, but here they are asking only for convex lens. So you don't have to draw this in your examination, you just draw this diagram only. Now read the second part. The second part is saying it is falling on concave mirror while passing through its principal focus. Means it is saying that now the ray is falling on concave mirror and it is passing through principal focus. So this also we have discussed in rule 2, that when a light ray is passing through focus, then after refraction what will happen, it will pass through it will become parallel to principal axis. So from the rule 2 we can see this is our answer. You don't have to again draw this diagram, because in the classes we have discussed for both, but in examination it has been asked only for the concave mirror. Now the third part, see, it is saying that it is coming oblique to the principal axis and falling on the pole of the convex mirror. So again this also we have discussed in class, and I have taken on slide from the previous class only. You can see this slide. Here what you can see, that the light ray is, when the light ray is incident on pole inclined at some angle to the principal axis, then it will reflect with the same angle, because the angle of incidence is equals to angle of refraction according to laws of reflection. Now see, we have drawn here both the diagrams, but here they have asked only for convex mirror. So you don't draw this diagram, you just draw this diagram only. And this all these video you can find in the part 1 of chapter 4, that is light reflection and refraction. So if you are having doubt in understanding this question, you can watch this video. You can see here that the answer that has came from board exam is shown here. See, for if you draw one diagram you will get 1 marks, second diagram you will get 1 marks, then third diagram you will get 1 marks. Why I have shown here? Because you have to look here what it is saying, deduct half marks overall if no arrows are drawn. So if you don't draw these arrows if you don't draw, then half marks will be deducted overall. Means if you haven't drawn in either of the diagram, if you haven't drawn this arrow, or in any in all the diagrams if you haven't drawn the arrow, half marks will be deducted. So if you are drawing everything and if you are not putting the arrows of the light ray like this, so they will deduct half marks, and you will not get this overall 3 marks, you will get 2.5 marks. Now moving further to the next question. The next question says, a coil of insulated wire is connected to a galvanometer. What would be observed if a strong bar magnet with its south pole towards one face of the coil. Means they are having a coil like this, they are having a coil this way, and they are having a bar magnet like this, which is having its south pole towards the coil. And what they are saying, that move it quickly towards it, and then moved quickly away from it and held stationary near it. See, this question, this exact question we have discussed in class also. So how we will going to write the answer of this question, this I will going to tell you. See what we will write. There will be a momentary deflection in the galvanometer as the magnet moves towards the coil. This will be the answer of the first question. In the second part it is saying that moved away from the coil. So what we will write there, again we will write, there will be momentary deflection in the galvanometer as the magnet moves away from the coil, but in opposite direction. This is very important that you have to write in opposite direction, because when you are taking it away from the coil, so what will happen, it will move in opposite direction. The galvanometer will show deflection in opposite direction. And the third, it is saying held stationary near it. So if it is held stationary near it, no deflection will be shown in the galvanometer. So this will be the answer of the third part. Now moving further to the next part, that is part B of this question number 23, it is saying that name the phenomenon involved. So we already know that the phenomenon is known as electromagnetic induction. This happens because of electromagnetic induction, and this law was given by Faraday, and we call that law to be Faraday's law of electromagnetic induction. Now the third question, it is saying state the conclusion based on the observation 1, 2 and 3. Means what you can conclude from the above observation, that is this 1, 2 and 3. From here what you can conclude. So what we can say, that the motion of the magnet with respect to coil produces an induced EMF across its end. Induced EMF means induced potential difference across the ends of the coil, and as a result induced current is set up in the coil, which is being measured by the galvanometer that is present. This will be your answer. So see, this we have discussed in our class, and see here from the slides, if you want to see, we have seen here that the procedure when we were seeing about electromagnetic induction, there I have explained that take a strong magnet and move the magnet in the direction shown in the figure. There I have drawn one figure also. So there also I have written the momentary deflection. This word is very important, that momentary deflection will be shown in the galvanometer, and deflection becomes zero as the magnet stops. The third part, that is saying when it is held stationary near to it. So and the diagram and the conclusion you can write from here. Again the slide that I have taken, that it states that the motion of the magnet with respect to coil produces an induced EMF across its end. And this diagram that I was talking about, the diagram, this is the diagram that we have seen in our class. So in our class we have seen from the north pole, and since it is saying that it is from the south pole, so you have to write here south pole, you don't have to write here north pole. And this, if you have any doubt regarding this, you can go to this chapter number 2, magnetic effect of electric current, and watch the part 3 of this chapter 2, and there you will be, if you are having any doubt, it will be clear to you. So see what the board has given the answer. The board has told that momentary diffraction in the needle in of the galvanometer to the left or right means in any direction. And in the second part, see what we have to observe, that these words are very important: momentary deflection, and in the second part the opposite direction. Means in the first part you have to write that momentary deflection will be shown, and in the second part momentary deflection with the opposite direction, and in the third part no deflection. If you write this no deflection also, you will get half marks. And answer to the second question, second part B, is electromagnetic induction, and in the third you will write like this, that induced EMF will be produced, and as long as we kept on moving the magnet, there will be induced EMF will be produced. And this is the marking pattern, that half marks you will get for part 1, half marks for part 2, and half marks for part 3, and for writing electromagnetic induction you will get half marks more, and for the conclusion you will get 1 marks, and total it will count to a total of 3 marks. Now moving further to the next question, that is question number 24. See, I have written both the questions, but the defects of the vision has been removed from the syllabus for this session, so we will not going to see first part of this question, but we will going to see the second part, because this second part is present in our, is still present in our syllabus. So the question 1, it is saying from the second part, the part A, it is saying red color is selected for danger signals. You have to explain, you have to give reason why it is happening. So we know that red color has maximum wavelength, or in other words we can say it has minimum frequency. Hence it is being least scattered by air molecules, fog or smoke that is present in the atmosphere, and hence it is being used for danger signals which can be seen from the longer distances that we have discussed in our classes also. Now the second part, it is saying that the sky appears dark in space. Why this happens, that sky appears dark in space? So sky appears dark in space because there is no atmosphere present, and hence no scattering of light takes place. See, these words are very important, whether it is scattering, whether it is dispersion, or whether it is the atmospheric refraction. So all the three phenomenon you have to remember it by heart, and you have to tell that by which phenomenon this thing is happening in the atmosphere. Now reading the answer, that the sky appears dark in space because there is no atmosphere in the space, and hence no scattering of light will take place, so we are not able to see the sky in dark space. The part C, it is saying the time difference between actual sunset and apparent sunset is about 2 minutes. Why this thing is happening, that actual sunset and apparent sunset is having a difference of 2 minutes? We know that this happens because of the phenomenon of atmospheric refraction. So the time difference between actual sunrise, or you can in bracket you can say actual sunset also, if the question will come for the sunset. So this question has come from sunset, so you just bracket this sunrise. So the actual difference between sunset is about 2 minutes because of the process of atmospheric refraction, that we see sunrise and sunset when the sun is below the horizon. So this thing you have to tell. So this is all the answer, and this we have discussed in our classes also. So I have taken one slide from the class, and see in this slide you can see that third point, it is telling that the sky move above the atmosphere appears black as there is no atmosphere and no scattering will take place. And in the part 6 we have seen that danger signs are of red color, and there I have explained that the same reason. And if you are not able to understand, you can watch the video of human eye and colorful world. And for advanced sunrise and delay sunset, see here we have seen. And if you are having any doubt in this, you can watch the video on chapter 5, that is human eye and the colorful world. Now moving further to the next question. Then before moving further, see what the board has given the answer to these questions. Red color is least scattered by fog or smoke and hence visible from the longer distance. The second, it is saying because of the absence of atmosphere no scattering will take. So these words are very important. Least scattered, this no scattering, and in the third part because of atmospheric refraction. So if you have written these three words, that is least scattered, no scattering and atmospheric refraction, you will get 1 marks for each question, and the total will count to the 3 marks. Now moving further to next question. The next question it is saying 2 lamps rated 100 watt 220 volt 10 watt 220 volt are connected in parallel to 220 volt power supply. Calculate the total current flowing through the circuit. These type of questions also we have discussed in the class. So see how we will going to solve this question. First of all, write whatever things are given. So we write given that P1 will be 100 watt, like it is written here, P1 is 100 watt, and for this P1 V1 is given as 220 volt. It is by mistake it is written 200, right here 220 volt. And P2 is given as 10 watt, and V2, this is V2 is given as 220 volt again. So we know from the formula that power equals to V into I, or you can write I equals to P upon V. So I1 will be equals to P1 upon V1, and when we will put the value of P1 as 100 watt and V1 as 220 watt, so what we will get 10 upon 22 amperes. Now calculate for the second bulb current, how much current the second bulb is taking. So that will be I2 will be equals to P2 upon V2, that will be 10 upon 220, and this will give you 1 upon 220. So since both the lamps are taking the current that we have seen, now we can add both the currents to have the total current in the circuit. So I will be equals to I1 plus I2, and this will give you a total of 10 upon 22 plus 1 upon 22, that will be equals to 11 upon 22, and when we will cancel this 11 upon 22, we will have 0.5 amperes. So this was very easy question. Now moving further to the next part of this question, part B, it is saying that two resistors X and Y of resistance 2 ohm and 3 ohm respectively are joined first in parallel and then in series. In each of the case, the voltage supplied is 5 volt. Draw the circuit diagram to show the combination of the resistors. So how you can draw when it is connected in series? You can draw this like this, that one is 2 ohm and other is 3 ohm, and the battery that we have connected is 5 volt. And for the parallel combination, we can put 2 ohm at top and 3 ohm at bottom and connect it to the 5 ohm battery. So this is the first part. Now in the second part it is saying that calculate the voltage across 3 ohm resistor in the series combination. So for this we can write whatever things are given, that X is given as 2 ohm and Y is given as 3 ohm and V is given as 5 volt. Now we know that R equivalent will be equals to, since it is saying in series combination, so for series combination R equivalent will be equals to Rx plus Ry, and this will give you 2 plus 3, which will be equals to 5 ohm. And then according to Ohm's law, what we can write, I equals to V by R. So V is given as 5 volt and R is given as 5 ohm. So this will 5.5, which will give you 1 ampere. Now you are having the total current that is flowing in the circuit to be 1 ampere, the voltage that is flowing through the 3 ohm resistor. So what we can write now, to calculate the potential difference across 3 ohm resistor, we can write V will be equals to I into R, and put the value of I and R. I is given as 1 ampere and R is given as 3, so it will come as 3 volts. Means 3 ohm resistor will consume 3 volt of or potential difference. Now moving further to see what board has given the answer for this. See, it is showing that I1 will be equals to P1 upon V. This is 100 upon 2. The similar way that we have solved, the first one I1 will come as 10 upon 22, the I2 will come as 1 upon 22, and hence when we will add, we will have 11 upon 22, and this will give you 0.5 ampere. So for writing this formula you will get half mark. For solving this you will get again half marks, and then again so finding I2 will fetch you again half marks, and when you will calculate you will get 1 marks for the addition of both the currents, that is I1 and I2. And for the part B, these are the two diagrams, the first diagram and this is the second diagram. For both the diagrams you will get half marks. And for calculating the net resistance, you will have R will be equals to R1 plus R2, that is 2 plus 3, that will be 5, and the same way that we have calculated, we will get I as 1 ampere, and when you will calculate you will get V as 3 volt, and this will again give you half marks, and all will count up to 5 marks. Now moving further to the next question. The next question, again it is question number 30. You can see that draw a labeled ray diagram to show the path of light ray incident obliquely on the face of glass slab. This question again we have discussed in our class. I will going to show you. The second question is of refractive index. The third question is of the power of the lens. And look here, either you have to solve this or you have to solve this part. So here in this part is saying a person is suffering from myopia and all these things. Again we know that this defects of eye is not in our syllabus for this term, so we will not going to see this part of the question. So we will going to look only for the first part of the question, and hence see the first question it is saying draw a labeled ray diagram to show the path of the light incident obliquely on one face of the glass slab. So again I have taken one slide from the video, from the previous videos. So see, you can see here this is a glass slab, and the same diagram you have to draw in your exams also. And now moving further, we want to solve this question, this part B, that is calculate the refractive index of the material of glass slab, given that the speed of the light through this glass slab is 2 into 10 to power 8 meter per second, and in air it is 3 into 10 to power 8 meters per second. So to calculate this, first of all we will going to write whatever things are given. So by the way, if you are having any doubt in this first part, you can watch this video of chapter 4, light, reflection and refraction. Of this chapter, part 6, if you will see, there I have explained in detail about this. So if you are having any doubt, you can go and watch that video. Now for question number this 30 part B, see what we will going to do, we will write whatever things are given. So what is given, that Vg means the velocity of light in glass is given as 2 into 10 to power 8 meters per second, and Va, that is velocity of light in air, is given as 3 into 10 to power 8 meters per second. Since from the formula we know that the refractive index Nga will be equals to Va upon Vg. This Va is the velocity of light in air and this Vg is the velocity of light in glass. So put the values of V and Vg as 3 into 10 to power 8 upon 2 into 10 to power 8, and this 10 to power 8 will cancel this 10 to power 8, this 2 will cancel this 3, and you will left with 1.5. So refractive index of glass slab will be 1.5. Now moving further to the next part of this question, it is saying calculate the focal length of the lens if the power is given as minus 2.5 diopters. So we know that first of all we write whatever thing is given, that is power is given as minus 2.5 diopters. So we know that the formula for power of the lens is P equals to 1 by F in meters or 100 by F in centimeters. So what we will going to do, you take this F here and take this P here. So if you are taking 1 upon P, it will give you focal length in meters, and if you are taking 100 upon P, it will give you focal length in centimeters. So put the value, and F will be equals to 100 upon minus 2.5, and this will give you 40 centimeters. So focal length will be equals to minus 40 centimeters, because one minus sign is here, or focal length will be equals to minus 0.4 meters. See, they haven't asked you about the type of the lens. So if they have been asking about type of the lens, so you can easily say that since focal length is negative, you can say that it is concave type of lens. So now see what the board has given the answer. The same figure that we have drawn, the same figure they have drawn here. And since see here, they have again said deduct half marks if arrows are not shown. Means this arrow, if you haven't shown, then half marks will be deducted. So if you are drawing this diagram, you will get 2 marks, and if you are not drawing the arrows, you will get 1.5 marks. And again the same thing as we solve. If you write this formula, you will get half marks. If you will write you will put all these value, you will again get half marks. And if you will write the answer, again you will get half marks. And for this focal length, see, this P will be equals to 1 upon P in diopters. So F will be equals to 1 upon P, and you will get, they have shown here that minus 4 meters, minus 0.4 meters, or you can also write the same, that minus 40 centimeters. So if you are writing this formula, you will get half marks, and if you are writing this answer, you will again get half marks, and if you are writing here this formula, you will get half marks. And see what they have told, that deduct half marks if unit is not mentioned. So if you are not mentioning the unit, again half marks will be deducted. So this was all about today's class. In this class, I have told you what is the pattern of the board exam and how the marking system is done. See, I have shown you all the marking patterns of the board exam, so that you can have a clear idea that how much things you have to write and what to left. The PDF of this file I will give you on the WhatsApp group, and if you are having any doubt, you can ask in the class or in the WhatsApp group. I will going to explain you. So this was all about today's class. Stay home, stay safe. Thank you. God bless you.